This is going to be a very quick demonstration of the Acuity white light chromatic confocal sensor. And here you can see this is our CCS Prima unit, and in this case we've got a CL3 probe. And the easiest way to describe this application is that on this sensor we're actually going to be taking a white light source, and we're going to go through a monochromatic lens, and it's going to break it into different colors, and then whatever surface it hits, that light will come back, hit a beam splitter, go through a small pinhole, and we have a spectrometer that's going to look at that wavelength of light, and then that'll be calibrated internally into the Prima, and we'll be able to measure any kind of displacement. The advantage of this technology is it's a very small spot size. It goes straight down and straight back up, so we can get into small holes, grooves, or pits, and it's very, very accurate. So in the application we're going to look at, the CL3 probe scan, which has a measuring range of 1.4 millimeters, and it starts from 12.7 out to roughly 14.1 millimeters. We're going to have a resolution of 60 nanometers, and it'll be accurate to plus or minus 200 nanometers. In this case, I believe we use the MG70 probe, which has an 8 micron diameter spot with a lateral resolution of 4 microns. So let's go ahead and look at the scan. And in this case, what we took is we actually went 3 millimeters by 3 millimeters, and we took a data point every 2 microns on the x-axis, then we jogged it down 2 microns and went back across and took another scan across there. So this was a very dense and very accurate scan. And let's go ahead and take a look at the surface. So if we wanted to take a look at this in 3D, here's that surface. And as you can see, we're really, these little holes here are probably a little dust on the surface there. And you can see we are really getting down into those areas. And if we wanted to, let's go back up to that 2D image and let's look at some of the profiles. And here you can see as we scan across there the profile, and let's just change that orientation. And with this, with the click of a button on that full profile, of course we can get our ISO numbers, where here you can see we've got an R sub A of about 10 microns, 10.7 microns. And if we want to, we can of course zoom that up, and let's look at the bottom of that trough. And here once again we can also take that, and this is to the ISO standard, ISO 4287. Here across the bottom of that trough you can see we got about a 2 micron R sub A. And just to give you an idea of the capabilities of this, let's zero this up again. And so over this smaller range here, you know, this is roughly 180 microns across there, and you can see the kind of data that we're picking up with this. And let's once again take a look at that particular surface measurement, and you can see, you know, that R sub A is about a 2 micron. With this probe, we should be able to do about a 3.5 to 4 micro inches of surface roughness. If it gets smaller than that, then we would probably want to go to a different probe model.